Ohm's law detailed description. The image explains Ohm's law, which is one of the most important basic laws in electricity and electronics. Ohm's law describes the relationship between voltage, V, current, I, and resistance, R, in an electrical circuit. It is represented by the formula V is equal to I times R, where voltage is the electrical force that pushes electrons through a conductor, current is the flow of electrons measured in amperes, A, and resistance is the opposition to the flow of current measured in ohms, omega. This relationship helps engineers and technicians calculate the unknown value of voltage, current, or resistance in any electrical circuit. According to the law, if the voltage increases while the resistance remains the same, the current also increases. Similarly, if the resistance increases while the voltage remains constant, the current decreases. The image also illustrates how electricity flows through a conductor. A conductor is a material that allows electric current to pass easily because it contains many free electrons. Metals such as copper, silver, aluminum, and gold are good conductors because their outermost, valence, electrons are loosely bound to the atoms and can move freely when a voltage is applied. When a battery or power supply is connected to a conductor, the applied voltage creates an electric field that pushes these free electrons through the material, producing an electric current. Since conductors have low electrical resistance, very little energy is lost as heat, making them ideal for electrical wiring, motors, transformers, and electronic circuits. This is why copper is commonly used in household wiring and electrical cables. The practical example shown in the image demonstrates Ohm's law using a simple LED circuit. The circuit consists of a 9-volt battery and LED with a forward voltage of 2 volts and a 470 ohm resistor connected in series. Before calculating the current, the voltage across the resistor must be determined by subtracting the LED voltage from the battery voltage. Therefore, the resistor voltage is 9V to V is equal to 7V. Applying Ohm's law, the current is calculated using the formula I is equal to VR, giving I is equal to 7V divided by 470 ohms is equal to 0.0149 A, or approximately 14.9 milliamperes, 15 mA. This current is suitable for operating a standard LED safely without causing damage. The resistor limits the current to a safe value, protecting the LED while allowing it to glow properly. The image also helps explain the behavior of an insulator using Ohm's law. An insulator is a material that does not allow electricity to flow easily because its electrons are tightly bound to their atoms and cannot move freely. Common insulating materials include plastic, rubber, glass, ceramic, dry wood, and air. These materials have very high electrical resistance, which prevents the movement of electric current. According to Ohm's law, when resistance becomes extremely high, the current becomes extremely small, approaching zero. As a result, almost no electricity flows through an insulator, making these materials ideal for protecting people and equipment from electric shock. A simple real-life example can be seen in an electrical power cable or a mobile phone charger. The inner wire is made of copper, which acts as the conductor and carries electrical current from the power source to the device. The outer covering is made of plastic or rubber, which acts as the insulator and prevents current from escaping the wire, protecting users from electric shock. Without the insulating layer, touching the live conductor could be dangerous. Therefore, both conductors and insulators are equally important for the safe operation of electrical systems. A simple way to understand Ohm's law is by comparing electricity to water flowing through a pipe. Voltage is like the water pressure that pushes the water, Current is like the amount of water flowing through the pipe, and resistance is like a narrow section of the pipe that slows the flow. A conductor is similar to a wide, smooth pipe where water flows easily, while an insulator is like a blocked pipe where almost no water can pass. This analogy makes it easy to understand why conductors carry electricity efficiently and why insulators prevent electrical current from flowing. In summary, the image demonstrates that Ohm's law, V is equal to I times R, is the fundamental relationship between voltage, current, and resistance. Conductors such as copper have low resistance and allow free electrons to move easily, resulting in high current flow, while insulators such as plastic and rubber have very high resistance, preventing the movement of electrons. The lead circuit example clearly shows how Ohm's law is used in practical electronics to calculate current and select the correct resistor value. Understanding Ohm's law and the properties of conductors and insulators is essential for designing safe, efficient, and reliable electrical and electronic circuits.